Okay, hello everybody. Thank you for staying. It's great. Great to be here. Great to have you here. For my keynote, Cluster by Cluster, Key Moments in the Cloud Native Ecosystem. My name is Anais Urlichs. Now, I don't have an intro slide, but I'm going to talk a lot about my experience throughout the past years, kind of who I am throughout this slide deck. Now, big shout out to the organizers for having me here. I want to kickstart the day with a little exercise. We all probably know that this is the Kubernetes logo. This is what it looks like. And I want you to take a second to think about what comes first into your mind. What are you first thinking of when you see the logo? It can be anything you think of. Just for yourself, take a moment in your mind. What is it? Just pinpoint that. Now, you might be thinking about big events, community events. You might be thinking about KubeCon when you first saw the logo. No, certainly right now you're probably thinking about KubeCon that I mentioned that. You might be thinking about KCDs, DevOps days. You might be thinking about trade shows, startups, exploring new technologies and what startups are up to these days. You might also be thinking about international travel. Who here is not from London? Hands up. Yeah, a few people. Who here is not from the UK? Who here flew in from? Oh, also a few people. Amazing. Welcome. You might also be thinking about exploring new cities. Or you might be thinking about the keynotes and the growing ecosystem, the thousands of people who gather to events to share their interest in the same technology. Or you might be thinking about the hallway tracks. Now, these are all different experiences, different parts that make up Kubernetes as well, as much as the technology. Now, going back 3 years ago, I got started in the DevOps space. Before that, I was working for several years in the Web3 distributed ledger technology open source space. And I was interviewing at a company called CodeFresh, who ended up hiring me. And the interview went something like this. Can you write about Kubernetes? Can you write about Docker? And I was like, of course I can do that. Of course I can write about it. I've never used Kubernetes before. I've never hardly heard about Docker before that, but they ended up hiring me. And I wrote my first blog post about Helm, Kubernetes, lots of different technologies. But at the time, as you can imagine, as I was doing my research to write my first blog post, my knowledge was something like this. I knew the definitions that I could find online. That was how far my knowledge, my concepts of the technology went. So for example, in the case of Kubernetes, the definition that you can find on the website is the Kubernetes, also known as KATE because of the 8 letters between the K and the S. It's an open source system for automating deployment, scaling, and management of containerized applications. This is what I knew what Kubernetes was. Now, if you read that definition and you already have existing understanding of or have used Kubernetes before, you will understand what that means. You will know what containerized application is. Now, at the time, I had experience developing demo applications, but I certainly never really packaged them up and deployed them anywhere else but a demo environment on a blockchain, which is very different from what we are doing here. Now, fast forward. At the time, I thought that everybody was using Kubernetes. That was when I was learning about this technology, and everybody was telling me how amazing Kubernetes is 3 years ago. I was like, of course, everybody must be using that already. Now, as you can imagine, since then, as I learned more, as I read more about the space and engaged with more people and had more conversations, my understanding of the technology grew over time and changed quite a bit. And so with that, I want to introduce you to a concept called schema theory, which is going to be important throughout this talk. When I was in university, I took several different classes in psychology, also cognitive psychology. And as part of cognitive psychology, you talk about and you read research about how people learn. How do they develop their knowledge? And schema theory is a branch of cognitive psychology that deals with how do we understand the world around us? How do we gather new information? How do we develop our understanding? Now, I have a 7-month-old niece, and she already has schemas in her brain about the world around her. And as she grows and develops, she's building more and more schemas on what's happening. So right now, she has a schema, she has a concept in her world of what her mom is, who are her parents. But she doesn't know yet that we call that concept a mom or a parent. Now, as we grow, we develop more and more schemas around us and it's just basically the description of how do we classify the knowledge the information that we gather. So, for example, somebody who's 2, 3, 4 years old and has their first train set will learn that a train takes people from A to B. But that person, that kid, won't have necessarily a concept of what a train station is. And as you grow and as you kind of interact with the world around you, and people explain your new concept, that's when those schemas build and develop on your existing knowledge. Now, similarly, when you're looking at a new technology, so when you're new, for example, to Kubernetes, and you're looking at the definitions, you're looking at what people are writing about, the different technologies that you can find, you're trying to connect it with your existing knowledge, your existing understanding on how things work. So, for example, I understood the different problems, the trade-offs that went on, for example, in the Web3 space, on running distributed ledgers around individual machines. And I tried to connect that knowledge with what I was learning about the cloud-native ecosystem. So in this keynote, I want to talk to you, first of all, about the history of Kubernetes. How did Kubernetes come about? Why was it developed? How was it developed? And when? Where did the need for the Cloud Native Computing Foundation come about? And then some key projects that also help to advance Kubernetes, the ecosystem, the technology itself. Now, if you're new to the space, I'm hoping to build on your existing schemas with this new information. If you're already familiar with everything in one way or another that I'm sharing in this keynote, maybe I'm giving you a different perspective, maybe I'm advancing your schemas in a different way. So ultimately, the goal of this keynote is to change your schemas, the way that you're thinking about the space. So, Kubernetes history, let's get started with that. We're in 2013, and at the time, every company is in one way or another becoming an internet company. More and more companies need to run their workloads, maybe even at scale. Now, I interviewed myself in my first jobs at companies that had their servers running literally next to their workstations. So you're either in like pure virtualization, running your own servers, or you're using infrastructure as a service, or you're already a company that's moving towards the cloud. Now, at that time, the majority of the market share in the cloud was at AWS. AWS was the dominant leader in the space. And Google at the time wanted to have a slice of that market share. They wanted to get involved. They wanted to apply their internal infrastructure expertise to the cloud and make an offering out of that. Now, they have already been using a form of containers by then in 2013 for years, for many years. They developed Borg, their internal containerization management system, 2003, 2004, around that time. So they already had the experience. And they basically want to apply that to the new trend of moving to the cloud. Now, this shift of more companies using containers or looking into containers or ways to better manage their application stack, that set the scenes for Docker. So in 2013 is also when Docker was introduced. And Docker really brought together developers and operation folks to solve the application problem of sorts of how do we better deploy our application stack. And this is what Kubernetes first built on. The first iteration of Kubernetes was to provide a declarative layer on top of Docker, an API where people can interact with and manage containers. Now, before that could happen, before the first version of Kubernetes could be released, the people internal of Google who were wanted to work on Kubernetes. They first needed approval, and the approval took like 6 months to get. And then they wanted to release Kubernetes, the first version, at the first DockerCon in 2014. Now, so they had another 3 months, ultimately, of developing the first version of Kubernetes and release that. Ultimately, with Kubernetes, the people who started it wanted to build an operating system that abstracts away the cloud, basically an operating system, a way to interact with cloud resources, to deploy your application where it doesn't matter which cloud provider you're using, that is a layer between the infrastructure, the cloud, and ultimately the application stack, the workload on top. So to do that, ultimately they knew at Google that they can't just do it from within Google. They can't make Google dependent on that technology and vice versa. But they need to gain a critical mass to get the interest from the community as a whole to build that vision. So in 2014, at the first DockerCon, Kubernetes was introduced at a keynote. And with that, also the first version was released open source. So while Docker made it possible to bring one piece of software together, Kubernetes was addressing the problem of how do we bring multiple pieces of software together? How do we manage that at scale? Now, at the time, Kubernetes wasn't the first or the only container orchestration system. There were multiple ones released at the same DockerCon. So for example, Facebook released Tupperware. Another big one was Mesos at the time. That was already open source. It was already used by companies. Now Mesos focused, instead of the API, they focused on the scheduler. So Mesos was already able to scale to thousands of nodes, versus Kubernetes at the time wasn't able to do that. They were managing several hundreds of nodes. So Netflix, for example, and other companies went with Mesos first. Now, Kubernetes was open source. Kubernetes gained more and more traction over time. Companies such as the developers from Pokemon Go in 2016, they ran for Pokemon Go on a single Kubernetes cluster, and that kind of interest and adoption and those trials then also further fed into the growth of Kubernetes. So here's the GitHub chart. You can see it's pretty steady over the years, and we are now over 100,000 GitHub stars. Now with that kind of growth, there are obviously several different problems that come along as well. And one of the problems that Kubernetes had to deal with very early on was open source governance. How do you govern distributed systems? If you want to build a distributed system, you want to have also distributed decision-making set up. And that's a problem that also I heard lots about in the Web3 space, for example. So this is something that I try to also connect with my existing understanding of okay, how did the Cloud Native Computing Foundation provide a solution or provide an option for open source governance? So at OpenSourceCon in 2015, the Cloud Native Computing Foundation was announced. And the main challenge here was that Kubernetes as a project, already had people who had clear tasks, who were responsible for different aspects. But because it was such a organic setup, you really had to connect with the people directly. So if you wanted to solve something, if you wanted to get input on something, a specific component, if you want to give feedback, if you had issues with some components of Kubernetes, you had to reach the right people to convey that. And so the challenge really was to slide a governance model underneath the existing structure. Now, the other thing is something that the Cloud Native Computing Foundation and the people who developed and worked on the governance structure for Kubernetes did really well. They didn't just focus on the issues that they had right in that moment, but they focused on how can they build a governance structure that will foster the growth of Kubernetes long term. And that's also what we see today with the different communities set up around Kubernetes and the CNCF to manage different aspects of the ecosystem. So at the end, the intellectual property of Kubernetes was moved into the CNCF. And Kubernetes was the first project to graduate from the CNCF in 2018. Now, if you're new to the way that projects advance within the CNCF, usually you apply to become a sandbox project. And then as you're a sandbox project, you need to get more and more contributors from different companies and advance the interest of that project over time. Now, at the time when Kubernetes graduated, it had over 50% of the Fortune 100 companies using Kubernetes in containers orchestration as their containers orchestration platform. And that showed, basically at the time that, or through that already, that Kubernetes was kind of going ahead in terms of popularity of the other orchestration platforms. Now, the thing is, I think many of you have heard this quote before: if you want to go fast, go alone. If you want to go far, go together. And that also applies to the Kubernetes ecosystem and how basically different projects contributed to Kubernetes. Now, it certainly helped that Kubernetes put a strong focus on the API layer, which allowed the ecosystem to advance over time. Now, I want to start off with monitoring as one of the projects that really advanced the ecosystem. You have to think about it this way. More and more companies move to containerized applications, move to containerized distributed workloads. And so, for example, Netflix in 2016, 2017 shared in this is a really good talk, their microservice architecture, the different layers, the different moving parts that they had and how they were working with it. Now, before 2016, 2017, when Kubernetes, container orchestration systems, when Docker became more popular, it was really difficult to gain insights into those different components, into those different layers. And that's something that Prometheus addressed. So Prometheus was created by engineers within SoundCloud in 2012 who saw that need for this, for a system that gave us metrics and insights on your different workloads. Now, it was open source, but it was kept low-key until 2015. And then they had a new open source manager come in who then promoted the project further. It was accepted into the CNCF at incubating level. Now that's the next stage above the sandbox level. And then it was under the CNCF governance, so it wasn't dependent anymore on SoundCloud and SoundCloud advancing Prometheus internally. It graduated as the second project within the CNCF in 2018, and really the focus of Prometheus was to drive observability of modern systems. Now, many of my information of the resources that I share with you are based on the Kubernetes documentary and the Prometheus documentary that were both released last year. So if you are curious about the history of different projects, then check out the documentaries of, I think it's by Honeypot. So next project that advanced the space, that advanced how we interact with containerized Kubernetes-focused applications workloads is Helm. Who has used Helm before? Hands up. Yeah, most of you. Lots of people know Helm because Helm is ultimately there to remove resource duplication, to manage multiple Kubernetes resources. We have now the containerization part, we have the orchestration part, but if you're interacting directly with Kubernetes, you need to write YAML manifests, and you don't want to deal with maybe hundreds of thousands of YAML manifests to manage your workloads declaratively. Now, Helm removes some of the resource duplication and allows you to manage, to better manage your application stack, define how your application is supposed to run in different environments. Now, this is the first blog post that I published in the space, not knowing what any of it actually meant, what I was writing about. But I got there eventually, I hope. So, Helm, package manager. I was the 10th project to graduate in the CNCF in April 2020, and at the time when I graduated, I had over 13,000 contributions from more than 1,500 different companies. Now, it was created in 2015 at a company called Days, which got later acquired by Microsoft, and it joined the CNCF as an incubating project in 2018. And that's also when it moved over to Helm version 3, so it had several different iterations. There are lots of CNCF projects that you will find that have maybe the same problem that they want to address, but the way that they address those problems changes quite over time with their different versions. So the main focus of Helm was really to reduce the deployment time, and then also not having, obviously, to manage different, the YAML manifests separately, one by one. So it allowed also engineers to get involved into the deployment process. The next technology, the last one that I want to highlight, which I think really advanced the space, is GitOps as a concept, as a deployment concept. Who has used GitOps before in one way or another, different projects? It's still a fairly new, I would say, new technology, new space. And this is me, my first workshop that I gave from home, also about Argo CD at CodeFresh. Now, within GitOps is in itself the principle of managing all of your resources through Git, whereby Git is your single source of truth, and everything that's within Git has to be basically the state that's defined in Git has to be reflected in your cluster. Now, the way that you apply the state in Git to your cluster, to your workloads, can be done through different projects. The two main projects are Flux and Argo CD. They both graduated this year, in 2023. And basically, while GitOps provided new deployment mechanisms, new way to interact with your resources, what I want to focus on as well is how operators and the principles of operators allowed us to advance the system forward. So while Helm is used, for example, to deploy specific workloads declaratively to our cluster and define workloads through the values files, operators allow us to codify manual tasks that we would do within our cluster in an operator, in a Kubernetes operator, in custom resource definitions that we apply to our cluster to extend the default Kubernetes API. So once we have operators running in our cluster, they can monitor specific resources. And they can either tell us about the state of the resources, or they can then apply specific actions to those resources. Now, these are the different projects that have graduated by now. Cilium has just been added, but when I took the screenshot last week, it wasn't there yet. But yeah, these projects plus Cilium. Now, the community. How did the community grow over the past years? These are the different KCDs, including KCD UK, that are happening now until, I think, the end of the year. If you're curious about other events in the space, check out the CNCF event site. Now, there are also lots and lots of different people who create resources for free out there for you to share, to get what they are working on, to get started in the space with new technologies. I myself rely heavily on other people's tutorials and how they set up certain use cases. Also, Kunal, who's speaking after me, has like a vast number of different resources and video tutorials that he's published in the space. Now, this is a challenge that I started when I got started in the space called 100 Days of Kubernetes. I'm not maintaining that anymore, but it might give still people some inspiration on what they could do to share their understanding of this technology. Now, lastly, there's a big ambassador network all around the globe. So if you have any questions, if you want to get involved, if you want to start a new initiative, or if you might not know if there's already an initiative existing for an interest or problem that you have, reach out to the ambassadors. I'm not a CNCF ambassador right now, but it's a great network, very welcoming people. With that, thank you so much for listening. Thank you so much for having me here. Here's my website.